Dear students, now we will see the contents of Unit 3. It contains basically three parts. The first is equilibrium, second analysis of beams, and third is forces in space. Out of that, we have covered the part of equilibrium in the class. Now we will start with the next part, that is the analysis of beams. Now in the analysis of beam, firstly we will see what is beam, a structure which is horizontal and on which the different types of loads can be supported. That is the beam. Now there are again two types, that is, if one beam is provided to balance the load, then it is a simple beam, and if the combination of beams which includes the two or three beams is provided, then it is the compound beam. The next is, depending upon the support specification, there are total 7 types of beams. We will see one by one in detail. The first one is the simply supported beam, a beam which is resting on the support at both the ends. That means on both the ends of the beam the support is provided. Then it is called as the simply supported beam. The length of beam is called as the span of beam. That is nothing but the distance between the two supports. The next type is overhanging beam. This beam is not supported at the ends, but there may be the intermediate supports and the part of beam is extended beyond that support, like this as given in the diagram. Now the next is cantilever beam. A beam which is fixed at one end and free at the other end is called as the cantilever beam. It is given in the diagram. Then the next is a beam with hinge and a roller support. As the name indicates, a beam which has a hinge at one end and a roller support at the other end is called as this beam. The next is a fixed beam. A fixed beam means a beam which is fixed at the two ends. That is called as the fixed beam. The next is continuous beam. A beam supported on numbers of supports is called as the continuous beam. The numbers of supports are more that means at the two ends also there are the support, as well as at intermediate points also the supports are provided. That is the continuous beam. The next is prop cantilever. A cantilever supported at end. In other words, a beam fixed at one end and supported at other end. These are the different types of beams. Now we will see the different types of loads acting on the beam. The first is point load or concentrated load, a load acting at a single point, and it is represented in the unit Newton or kilonewton, like in this diagram. Here the beam AB is there, on which there are 2 point loads acting, W1 and W2 at two different points. W1 and W2 are the point loads. Then the next is uniformly distributed loads, a load which is spread over the beam or part of beam uniformly. It is represented in Newton per meter. The uniform distributed load can be converted to a point load by taking the product of intensity of the UDL, which is given over here Newton per meter, and we have to multiply it by the distance or length of the beam, and this point load will act at the center of this uniformly distributed load. For example, here one beam AB is there having the length L and its load W per meter is given. So we can convert it into the point load as which act at the center of the beam, L by 2 distance, and its magnitude is W into total length L. Then the next is uniformly varying load, a load whose intensity varies linearly between the 2 points on the beam is called as the uniformly varying load. There are some examples over here of uniformly varying load. That means, suppose we will take the example of triangle. Here the load intensity is given W by meter and the length of beam L. Now in case of triangle, the reaction will act at the distance of L by 3 from this side. That it depends upon the CG point. Okay, the distance of CG point of that triangle. So it is L by 3 from end B, and from end A it is 2 L by 3, and the magnitude of that point load, that is equal to the area of triangle. Then the next is, if like this the uniformly varying load is given, in that case what we have to do, we have to divide this area into two parts, rectangle and the triangle. So for rectangle, what will happen, the reaction will act exactly at the center and its magnitude will be W1, that is this W1 by into L. And for the triangle, the magnitude of that point load will be 1 by 2, that is the area of triangle, 1 by 2 into this length L, and now this distance, that is the W2 by W2 minus W1. Now the next is, for this type of triangle, the reaction will act exactly at the center and the magnitude will be 1 by 2 into W into L. Now we will see the next type, that is the varying load. A load whose intensity varies between the 2 points is called as the varying load. In the given diagram, it represents the varying load. To convert it into the point load, firstly calculate the area of the given loading by integration, then coordinates of centroid, which represents the points of concentrated load. So we will not go in detail for this because it is not there for numericals. Now we'll see the next is compound beam. When two or more beams are joined together by means of internal hinge or roller, the combination is called as the compound beam. Now we'll see it by representation of diagram. Here beam AB is connected with the beam BC with the help of internal hinge at point B, as well as the beam BC is connected to the beam CD. At the point C, the internal hinge is there. Okay, so here the beam AB, BC and CD are connected by internal hinge, so it is a compound beam. In the other representation, it can be given the compound beam like this also. Beam AB is there at point A, fixed support, at point B, roller support. That beam AB is resting over the beam CD at point C. Here it is support, fixed support, as well as at point D, fixed support. So now we'll see the analysis of this compound beam. Firstly, we have to disconnect the beam by internal hinge or roller and draw the free body diagram of each beam separately. Now means, if we have taken the example of this, we have to firstly draw the free body diagram, disconnect these two beams, that means beam AB and beam CD separately. You have to consider, then draw the free body diagram for each beam separately. And now we have to convert these supports, that is for fixed support 2 reaction, roller support 1 reaction. After that, we have to apply the conditions of equilibrium to each beam to find out the magnitude of reaction at each point. The last point of theory, it is determinate and indeterminate structure. If in a structure the number of unknown quantities are less than or equal to the number of static conditions of equilibrium, then it is called as the determinate structure. For analysis of this structure, equilibrium conditions are used. If in a structure the number of unknown quantities are more than the conditions of equilibrium available, then it is called as the indeterminate structure. For analysis of this structure, equilibrium conditions are not sufficient, but it requires additional deformation condition for analysis. Here it ends the theoretical part related to the analysis of beams. Now we will see the numericals.